this is chapter number 21, and the problem I will start from chapter number 21. I will start from the problem number 41. Okay, so 41 says a body thrown up with some initial velocity reaches a maximum height of 50 meter. Another body of double mass, double mass thrown up with double the initial velocity. How much height it will reach? So this is the requirement. A first body is thrown upwards whose mass is, let's say mass is m, and the initial velocity, because that will reach up to maximum height, where final velocity v final you can say will be 0, v initial will be something, let's say v, or you can say u, and the height it has reached is 50. Now a second body of mass is equal to double of the mass of the first one. Final velocity obviously to be 0 because it is reaching the maximum height. Initial velocity is saying the double of the initial velocity of the earlier one. So what would be the height h1 for it? This is the requirement. Now as you see, in any of the motions equation there is no you can say the no indication or any involvement of mass in any of the equation. That means the motion is not depend on the mass, as because in kinematics we don't study the cause of the motion, rather we study the motion itself. So in that any of the equation there is no involvement of mass. So on the mass any of the motion is not depends. It depends only the initial, final velocity, acceleration, time, the distance it has to cover, or the height it has to cover. So this is the only, so it does not depend on the mass. So this way, this is a superfluous data that to confuse the student. So need not to confuse, because only will work on the height. So the height and the velocity is related without a mention of time is v square is equal to u square plus 2gh. Here as the motion is upward, so this g will be negative, so because that is moving upwards means against the gravitational pull, so acceleration will be opposite to the force applied. So in that case acceleration has to be considered as a negative, because force and acceleration should be in the same direction, then we'll say it is working. So it is against the force, so that means g will be negative. So we will use this formula. Now for the first case, v final is equal to 0. You have taken u square, then is equal to minus 2, g will be as it is, and h I have taken, h is given as 50. So from here you understand u square is equal to 100 g. So this is your first equation. Now if I move to the second equation, the data given, we can say the same expression we can use. In that case final will be 0, initial will be, instead of u, that will be 2u whole square minus 2g, and h I have taken h1. So if I take 2g h1 one side, it will be 4u square. Now putting the value of u square here, I will get 4 into 100, that means 400 g. Now g is on the both side, 2g h1, so I will cancel out g. 2, if it is cancelled this part, so h1 will be 200 meter. So the initial height was 50 meter, and the second case the height will reach is the 200 meter. So this is the requirement of the sum, or the need of the sum. So moving to the next problem number 42. So problem number 42 says a ball is released from the top of a tower. A ball is released from the top of a tower of height h meter. It takes t second. It takes t second, or capital T, sorry, t second to reach the ground. To reach the ground. What is the position? What is the position after t by 3 second? So that means it is being dropped from a tower. Let's say that this is the tower and it is ground. This height is h. Is dropped from initial velocity 0, freely dropped, and it takes the time. The h is covered the time t. Now after, let's say t by 3, means this much, let's say it is covered by t by 3. So what is the position? That means from here, if the height is h1, so what is h1 here at t by 3? So this is the need. So first you have to establish some relation with h and t. If we take the total travel is h height and time is t, so h is equal to, what is that, u t plus, it is falling down, so g will be positive, t square. U is initial velocity 0, so h will be equal to 0 plus, need not to write that, g t square. This is first equation. So for second equation, if I consider the start point is same, so height h1 will be u will be 0, then only the second component half g. This case t will be t by 3 whole square. So it is half g t square by 9. So you can see half g t square, it is h. So ultimately it is h by 3. So this will be a relative height. If I take the total height is h, and this height after t by 3 will be t by 9. It is the t by 9 from the initial position downward. Okay, if let's say the ball is at h height initially, so after t by 3 of fall, it will reach h by 3. That means it is h by 9, sorry, it's by 9 height. Okay, so moving to next, this is 43. The time taken by a vertically projected body, the time taken by a vertically projected body before reaching the ground, So this case, the problem is that this is ground, a body is projected up vertically, it has reached some point and then coming back. So let's say this height is h, the time taken to reach the highest height, let's say t1, and that to coming down is t2. The total time will be then t1 plus t2. So now look at the initial motion when it is moving from bottom to the reaching at height. What would be the, if is assuming h is the height, so h will be the initial velocity will be u. Okay, better not to use this one. This will be a quadratic equation. Rather use the single. So the velocity at for first it will be v after reaching highest height. So v final will be 0. V initial will be something. So you assume v final will be 0. V initial will be u. So that equation is equal to v final is equal to v initial, and if it is moving upwards, so it will be g, and the time taken is t1. So v initial will be u is equal to, I am putting this is equal to 0, this is u minus g into t1. So t1 is equal to u by g. Okay, now in the second equation, notice v is equal to 0, then reaching the ground. The equation, if I use, this is first equation, let's say t1. So for second equation, t, what is the t? V is 0, v initial will be 0, v final will be something. So if I take the t value, that will be, h will be, that I am assuming h, the height is equal to ut, u is equal to 0, that means ut plus ut2, I will say rather, half into g into t2 square. Now this part is 0 because initial velocity is 0, so h will only become half into g into t2 square. So from here I can say t2 is equal to under root of 2h by g. Okay, So what is h here? H will be considered as the maximum height before it is coming to 0 when it is thrown up. So this will be the T2, this is T1. So now U is unknown. So U something, if I can represent it in the form of h, that will give you a meaning, because h is the condition if for any velocity, if it is thrown, it will go to a certain height. So the projected body reaching the ground, so it has to reach the maximum height with any velocity is thrown, then after it will come back. So it will be universal if I consider the h. Okay, so now you have to task is to consider. So in first case, if v final square is equal to v initial square minus 2g h, if I consider, so this will be 0, this will be your u square minus 2gh. So what is u square is equal to 2gh. Okay, so u is equal to what? U will be under root 2gh. So if I want to put this value, I'm to rub it to get some space. So this is your T2. Just remember this is T2. So T1 will be, if I put u value, under root 2gh by g. So now it will become 2h max, because h is the max, and 1g will be cancelled out, and there will be g on the under root. So T1 and T2 value is same. So the total value will be the 2 of under root 2h max by g. Okay, this will be your answer. 2 into 2h max, whatever the maximum height it will attain, by g will be the your total time taken from the time it has thrown and coming back to the ground again. So this is 43. Moving to 44. Problem number 44. It says from an elevated point, from an elevated point P, a stone is projected. A stone is projected vertically upwards when it reaches a distance, d below p, its velocity is doubled. Its velocity is doubled. The greatest height height reached above P is how much? Okay, this is the sum. Now let me draw a diagram. Let's say this is some height, this is ground, this is at point P. From here a body is thrown and it is moving in this way. Okay, so it is thrown upward first, reached a height, let's say with reference to the P point it is h. Then after, when it is reaching at point, d from P, it has attaining double velocity. That means if it is 2u, this will be this is u, this will be 2u. But direction obviously it is changed. But we will consider the motion differently, the upward motion differently, and also there will be no confusion then. For the first motion, when it is moving up, the final velocity has to be 0. It is attaining final velocity has to be 0. It is attaining maximum height. Initial velocity will be the u. I have assumed that it is thrown with the initial velocity. Height is equal to, that height is h, say. So that equation will become v final square is v initial square, and when it is upward, that means it will be what? Minus 2gh. So this will be 0 is equal to v initial is equal to u square minus 2gh. So u square will be 2gh. H is the highest attaining velocity. H is the highest attaining height. Okay, highest height, attaining height. And if I consider the downward motion, so in this case v initial will be 0, v final is 2u, and height is equal to h plus d. We consider this is height is h. This case also, if I consider height with a different letter. So your equation will be v final square v initial square plus 2 into g into height, as it's this case. So v final is equal to 4 u square is equal to 2g, h is equal to small h plus d. Now u square is equal to 2gh, so you can put it 4 into 2gh is equal to this one, 2g small h plus d. Now if I rub it and I will write it here, what is that? 8gh is equal to 2g h plus d. So 2g, it will be 4, so 4h is equal to h plus d. So h is equal to highest attaining is equal to 3h is equal to d. So from there you can say h is equal to d upon 3. So whatever d is given, the highest attaining height will be 1/3 of the d. So this is your result. So this is for now. In the next video I'll move on to chapter number 22, and the problem will start from 45. Thank you.